All right. Okay. Bismillahirrahmanirrahim. Assalamualaikum. So today, um, we're going to start with a new topic, which is chapter number 3, estimation. So before we go to estimation part, let's revise back our knowledge on a previous chapter. So we already learned about population, the definition of population, which is all member in the study area, right? And we also learn the definition of sample, means a portion from a population, and some method in sampling, which is we have two type of sampling, which is random sampling method and non-random sampling method. So under random sampling method, we have really learned 5 methods actually. Simple random sampling and what we call as certified sampling method, systematic sampling method, and then cluster and multi-stage, right? Can you hear me? Boleh dengar?
Yes, sir.
All right, good. So so now why we do a sampling? Because when we have a very large population, so it is nearly impossible to take all members in the population. So that's why we do a sampling process, so we can infer back to the population, right? So that is the purpose of doing sampling lah, right? Because we want to infer back to the population, and we have very large number of members in the population. That's why we do a sampling. So we do a sampling to reduce, we employ a sampling method to reduce bias, selection bias. We want to increase the accuracy of making a prediction, estimation to the population. So that's why we're going to learn this chapter, which is estimation lah. So recall back to the chapter 1, we already learned about the definition of parameter and statistic without S. Right? This is the difference between statistics with S. Statistic with S means that the field of statistics itself means how data is being collected, organized, and then we analyze, interpret, and present, right? For parameter means that the numerical summary of population, and statistic is a numerical summary compute from the sample. So this is some example, right, of statistic and sample. So for sample, the sample size is, the notation for sample size is small letter n, and for population is capital letter N. Right? For mean, the sample for statistic is X bar, and for population is mu. Variance is S square, and for population is sigma square for population, right? Wait, All right, sorry about that. Boleh dengar? All right. For symbol for standard deviation is for statistic is s square s saja, right? For population is sigma. This is a symbol that we're going to use for uh, estimation lah. So all this symbol we call as a point estimator. So this is all the symbol here, x bar, mu, s, and sigma we call as estimator. So the value that corresponding to that estimator we call as a point estimate, right? If you could look at the on the left hand side, so let's say x bar equal to 30,000 ringgit. So x bar is a point estimator for sample, and this one is called as point estimate, right? Boleh. So yang lain-lain you boleh baca sendirilah. So this is x bar is a point estimate for mu lah. Point estimator actually. Point estimator. Right. So I hope you're clear about the point and the definition for point estimator and point estimate. So again, I emphasize dekat sini, x bar here we call as point estimator, and the value corresponding to the estimator is called as point estimate. And we need to remember the symbol x bar is specifically designed for statistic, which is sample, and mu is the mean for population, which is parameter, right? So this is very basic introduction, right? So I hope you understand the difference between a point estimator and point estimate, right? So the symbol for a point estimator is different based on statistic and parameter for sample and population. So before we dig in further into a point estimation, let's look into the sampling distribution for sample mean, right? When a sample is drawn from the population, there are many different samples that could have been chosen. As I illustrated before, let's say you want to find, let's say you have a population here, you have capital N equal to 5,000. You could have, you could take many samples. This is going to be sample 1, sample 2, sample 3, and so on lah. And each sample would have different sample size. This is N3 will be something, N2 will be something, right? So this means that the mean of the sample, right? The mean of the sample is called as x bar, will vary depending on which sample is picked, right? So the mean here will be different. Mean S1, S2, S3 will be different lah. So we should expect we have going to have x bar 1, x bar 2, x bar 3, right? Because we have a lot of sample in each, a sample size in each sample lah. So the sampling distribution of the statistics is depending on, right? So I just baca sini ya. So nanti kita akan tengok example. So the sampling distribution of statistic depend on the distribution of the population, the size of the sample, and the method of choosing the sample. So this is based on sampling method that we have learned previously in chapter number 1, right? Either random sampling method or non-random sampling method. Let's look at the example. This example. Suppose that a class has a population of 30 students and a lecturer wants to know the average mark of the students. So if you take average of these 30 students, it will be the mean of population. So that's why we're going to use the symbol of mu. So the mu will be summation of x divided by capital N, which is the total number of sample size. So we need to add all marks for each student and divide by a number of students. So this is number of students in this class is 30. So we have divide by 30. So we got 36.9. So this is the average of the population. So average of population, right? So the standard deviation is still same as the formula is still same as sample, but if you look closely, if you look at the sample standard deviation, right? This formula will be summation of x square divided by summation of x, and then you square divide by n minus 1, everything divided by n minus 1. For population standard deviation, which is sigma, so it's just same as sample standard deviation, but the denominator is different. Instead of taking n minus 1, right, we just take n only. So summation of x square minus summation of x square divided by capital N, everything divided by n. Right? Kejap Alright. Sorry about that. So banyak pula orang call hari ni. Okay. So this is the symbol for this is a formula for population standard deviation, which is this is still same as sample standard deviation, but the denominator for each value, right? Instead of we are using n minus 1, we are taking capital N, the whole number in the population, right? This is a formula, standard deviation for population. If you look at the example given, so it divide by capital N, right? So we will get 10.4 marks standard deviation. So let's assume lecturer draw random sample 5. Means that it take 5 observation, 5 students out of 30 students. So now the average of that 5 students will be called as sample. Right? We're going to use a different notation to indicate the average of 5 students, marks of the 5 students. So summation of x divided by n, we will get 32.6. So 32.6 is the point estimate of the mu. The mu is our point estimator, right? This is a point estimator for population, and this is a point estimator for sample. So now, how closely the value is to the population, right? 36.9. So nampak tak? Dia sedikit divert from the original value mean of the population. So that's why by taking single sample will not represent the whole population. That's why we need to take some samples, right? Maybe 2 or 3 or another 5 sample to infer back to the population. So we can conclude the whole population by taking several sample. Right. Kejap lagi ada orang call lagi. All right. So to answer this question, we need to use a concept of sampling distribution with sample mean. So repeatedly draw another 5 sample, right? So we will get the value something close to 32.6 again lah, because sample mean is vary from sample to sample lah, right? So let's say kita tengok sini, okay, sample number 2 dia ambil sini, X bar 2 dia dapat 35.2, X bar 3 dia dapat 33.4. So from these 3 sample, we can find the mean of the sample mean of the mean. So we will get 33.7, right? So 33.7 still divert sikit daripada the whole population, right? So the concept yang saya nak terangkan kat sini, right, bila kita ambil lagi banyak sample, when we take a lot of sample, so we will get approximately to the normal population, means that dia akan lebih ke arah the true mean. The true mean is the population mean lah. If you look at the original mean, right, for sample number 1, we get 32.6, right? And then the mean of the mean, we will get 33.7. Means that dia akan divert, dia akan pergi ke close to the original or true mean lah. Right. So let's keep this one. Let's look into central limit theorem. Alright. So before we go to central limit theorem, kita baca sini dulu sikit. Right. Page number 60. Okay. Suppose that a random sample of n observation is taken from a normal distribution with a mean mu and variance sigma squared. Each observation xi and 1 until n is of the random sample will have the same normal distribution of the population being sampled. So nampak tak apa yang dia nak terang kat sini? Kalau kita ambil the same population from a normal distribution, so semua X bar ni dia akan berada dalam distribution yang sama lah. Itu yang dia nak bagi tahu. So this is very important to know, because it's not going to be another type of distribution. It's still under the same type of distribution. So now, when we talk about a normal distribution, right? So I belum introduce dekat you a normal distribution, tapi I dah banyak cakap berkenaan dengan normal distribution. Normal distribution is a bell-shaped distribution, right? It's a bell-shaped curve lah. Maksudnya, it's a symmetrical distribution. Means that area on the left-hand side would be equal to area on the left-hand side. Maksudnya sama saja. Dia akan symmetrical lah. Maksudnya area on the left-hand side is equal to area on the right-hand side. So if this one is 50%, so on the right-hand side also 50%. And the total area will be 100%. So this is a normal distribution. So normal distribution, let's say X is having a normal distribution. This is a symbol of distribution sample. So kita letak N. This is indicating normal distribution. It consists of 2 parameter. The first parameter is mean, mu, and the second parameter is variance. So this is a characteristic of normal distribution. So when we take a several sample, right? A several sample like this, right? Macam ni, kita ambil banyak sampel, mean 1, mean 2, mean 3. So now it will become a sampling distribution. So normal sampling distribution. So dia stay dalam normal distribution. So dekat sini dia punya distribution will be the parameter involved for the sampling distribution will be mu, which is mean, and the standard error. Standard error means that sigma divided by square root of n. And this one should be squared lah. Right? Sigma ataupun lagi mudah kita letak macam ni lah. Become like this. Sigma squared over n. Right? So this is what we call as a standard error. So this is what we call as, this is variance. So boleh relate tadi I cakap berkenaan dengan this part. This part means that when you take a several sample from a normal population, right? When we take a several sample from a normal population, so normal population X for each observation would be have mean and variance for a single observation. But when we take a several mean, right, for each from the same population, it will have X bar, the mean for each sample will have a same distribution, which is normal distribution, but the parameter involved is a slightly different, which is mean and the standard error. Right. So this is the difference. Ini yang nak bagi tahu ni. Right. So when we are dealing with mean sampling distribution of the mean, so we need to calculate a standard error. Means that we need to consider the sample size as well. Boleh faham? Ada soalan tak setakat ni? Any questions so far?
No, sir.
Right, boleh faham? So now let's look at the next sentence yang dia bagi tahu dekat sini. If the sampling from a population with unknown distribution, right, the sampling distribution of X bar will still approximately normal with mean equal to mu and variance equal to sigma squared over n, provided the sample size is large. This is known as central limit theorem. Right? Contoh, I boleh bawa contoh sekejap. I bawa, I try to pick one. Okay. Dia tak nak buka kejap. I just nak tunjuk dekat you what is the meaning of central limit theorem. Sekejap. Kejap my computer a bit slow today. I don't know why. Okay, boleh nampak screen I?
No, sir.
Belum lagi. Okay, kejap. Alright. Okay, let's say I tunjuk satu contoh. Let's say histogram. Let's say I buat satu random number, normal random number. Let's say I ambil 30, right? So we boleh nampak dia punya histogram macam ni kan. So kalau 30 sampel, boleh nampak I punya screen kan. So let's say I increase the number of sample, let's say 200. So dia become approximate to normal distribution. Nampak tak ada perubahan graph ni? This is a histogram from this is a R programming, right? So kalau I ambil 30 sampel, dia macam ni. Bentuk dia is not really clear normal distribution. Kalau I increase kepada 100 sample, 100 observation, the graph would approximate to normal distribution. Let's say I increase more, let's say I tambah 200, right? So the graph is more towards to normal distribution. Let's say I tambah lagi 500, so dia nampak tak perubahan dia? So I tambah lagi 1000, so dia lebih kepada normal distribution shape, right? Ataupun bell shape or symmetrical shape, right? Boleh faham? You get the idea? Means that in the central limit theorem, I kena tukar lah, I share the whole screen lah. So senang you nampak. Right? The idea of a central limit theorem, dia kata dekat sini, a central limit theorem states that the sampling distribution of any statistic will be normal of on approximately normal distribution if the sample size is large enough. Means that kalau kita tambah sample size tu, lagi banyak sample size, let's say kita tengok perubahan dia daripada kalau kita tengok dekat sini, this is a sample size for 30 sample size. Kalau I increase to 200 sample size, so the shape become approximate to normal distribution. Kalau I increase lagi to 1000, so the shape of the distribution is exactly or approximately to normal distribution. So this is the idea of central limit theorem. Means that in the central limit theorem, bila kita tambah sample size, so the distribution will be approximately to normal distribution. So in most of the book, in statistics book, it says that when the sample size of n is more than or equal to 30, this is considered as large enough, right? But as I already simulate to you just now, right? When the sample size is 30, kita nampak kat sini, dia tak membentuk lagi normal distribution. When we increase the sample size more, 200, 1000, so then kita nampak dia lebih kepada normal distribution. So as in the book says that more than 30, so we will stick more than 30, even though I will not really agree on 30 lah. As kita tengok tadi, 30 dia tak menunjukkan normal distribution shape lagi, right? So now this is just a fundamental lah, belum kita masuk lagi practical dia. So if X bar is the mean of random sample size n taken from a population with mean mu and the variance sigma squared, so the limiting form of the distribution is uh, z equal to x bar minus mu divided by sigma over square root of n. So z here is a standard normal distribution, right? This is a standard normal distribution. Standard normal distribution, tadi kita tengok the characteristic of normal distribution, right? This is a normal distribution, which is the PDF. I tak boleh tunjuk PDF lagi. So which is the distribution size is mu and sigma squared. This is the parameter involved for the normal distribution. Mu here can be any real number, right? And mu and sigma squared lah, can be any real number, any number lah, right? But for the standard normal distribution, it's still under, it still have a shape of normal distribution, right? Which is the area on the left hand side is equal to the area on the right hand side. So just need to make sure you understand and take note whatever I said just now. The area on the left hand side is equal to the area on the right hand side from a negative infinity to infinity, same as for normal distribution lah, from negative infinity to infinity. But the difference of normal and standard normal distribution, the mean or x bar is equal to 0. And the standard deviation here is equal to 1. So that's why for standard normal distribution, Z is having a standard normal distribution when n equal to, and the mu is equal to 0 and the variance equal to 1. And this is Z. Right? So that's why the symbol is different. Instead of using X, we are using Z, this symbol. So this is the standard normal distribution. So dia kata dekat sini, in the central limit theorem, when n is approaching to infinity, the standard normal distribution will be mu is equal to 0 and variance is equal to 1. So the term of standard error, sigma divided by square root of n, is known as standard error lah, for the sample mean. As I said before, when we have a single observation, so we just take two parameter, mu and variance. When we have several samples, right, we want to measure the distribution of sample mean, then we have two parameter, mu and the standard error, which is sigma squared over n, right? So this is just an introduction lah. So the normal approximation of x will generally be good if n is more than or equal to 30. So when the sample size is more than or equal to 30, we will use this formula, right? We will use Z formula, which is standard normal distribution, right? When n is less than 30, which is a small sample, we will not use a standard normal distribution. Dia kata kat sini, if the population is not too different from the normal distribution, right? If and only if each observation is taken from the normal distribution. You faham tak apa yang cakap? Macam ni, let's say we have a population, let's say n equal to 28, right? This is the population size. So we know that from this population, we have a normal distribution. But instead of having sample size more than 30, we have less than 30. So that's why we still assume this observation, each observation from the population is still normal distribution, but we need to use some modification. This modification known as T distribution. So T distribution is look like normal distribution because it came from a normal distribution. The difference is, this is a mean, the difference is the sample size for this population is not large enough. It's only have less than 30. Right? When they have a less than 30 from a normal population, so it still look like a normal population, but we need to do some adjustment. This adjustment called as a T distribution. Boleh faham? Boleh clear? So dekat sini apa yang nak bagi tahu? So we depend on sample size, population, right? We have mean, right? So there are two type uh, of distribution yang kita boleh guna. When the sample size is less than 30 and the sample size is more than or equal to 30. So when the sample size is less than 30, we're going to use T distribution. This is from a normal population lah. Normal population. When the sample size is more than 30, we will use Z distribution. Z distribution is also known as a standard normal distribution. This is known as student T distribution. Alright? Boleh faham setakat ni? Any question? Before we go further on normal distribution. Ada soalan tak? So nanti kita akan bincang dekat sini whether the population mean, population standard deviation known, population known, standard deviation known, population standard deviation unknown. This is same lah, benda yang sama. Kita akan tengok lagi detail nantilah. So now, let's look at into a normal distribution. Ada soalan tak before we go to normal distribution? Or you want to take 5-minute rest?
5 minutes less, okay.
Mana yang lain? Tak nampak webcam buka. So kita tunggu, kita rehat 5 minit, right? We will be back on 10 minutes lah. We will be back on 9:50 lah, 9:53, right? Alright, boleh kita continue? Alright, let's look at into normal distribution. So tadi I dah briefly introduce ke you what is a normal distribution, right? So I hope you already download the the statistical table that I already provide to you in Google Classroom. Please download the Google statistical table. So this is a statistical table that we're going to use lah, right? Basically, this is a third edition. We have a newer version, fifth edition or fourth edition. I don't remember. The cover is on red color lah. So let's look at normal distribution. So normal distribution is the most used statistical distribution, right? Most used statistical distribution. The principal reason are normality arise naturally in many physical, biological, and social measurement situation. In fact, in medical, clinical condition also, we are using normal distribution. So that's why normal distribution is widely used in most of the practical situation. And it is very important in statistical inference. Means that most of the parametric tests of statistical tests are relying on normal distribution. Means that many people lies at the most situation, and less people will be on the diverse or dispersed area. Right? This is the right hand side and left hand side. This is going to have a very minimal observation, and most of our observation will be on the center. That's why the mean of the normal distribution will be on the center lah. And we know that from the previous explanation, in this normal distribution, right, it consists of 100% of area under the curve. So this is the curve, right? So area on the left and on the right hand side consists of 50%, and the area on the left hand side also 50%. Means that, let's say we want to find this area on the right hand side is also equal to area on the right hand side. So this total area here will be the same as the total area on the right hand side. So under normal distribution, it takes two parameter. It consider two parameter, which is mean and standard deviation. Mean in measure in is a measure of central location, and standard deviation is measure of spread lah. So that's why tadi I introduced dekat you, when X is having a normal distribution, so the symbol will be X tilde normal and with two parameter, mean and variance. You boleh dengar I punya suara kan? I dah unmute. Okay, good.
Boleh, sir.
So, let's look at the characteristic of normal distribution. Benda yang sama, basically benda yang sama lah I bagi tahu dekat you tadi. So it has a bell-shaped distribution, shape curve or symmetrical about the mean, right? So mean dekat tengah-tengah, and the total area under the curve is always 1, which is 100%, and the area or distribution of each side is 50%, which is 0.5 lah. So if the total area is 1 and each side is 0.5. So why 1? Because we are measuring the distribution in terms of probability. So the probability of X for lies should be between 0 and 1. Right? The probability of X should be 0 and 1. It cannot be negative probability value lah. But for normal distribution, right, the value can be either from negative infinity to infinity, right? So this is the normal distribution. Now let's look at the standard normal distribution. The standard normal distribution, I already explained it to you. When we have mean equal to 0 and standard deviation equal to 1, then the observation of X is called is having a standard normal distribution. The formula for standard normal distribution is Z value. So Z is equal to X minus mu divided by sigma. So this is for a single observation. Right, for a single observation, mean X minus mu divided by sigma. When we have a sample distribution, mean of a sample of mean, let's say X bar, right, or Z bar. So Z will be X bar minus mu divided by sigma over square root of n, where square root of sigma over square root of n is called as standard error, right? So now let's look at the step to find the probability value, right, in the standard normal distribution. So as I said before, normal distribution is measured under by using a probability value, and the probability value should lies between 0 and 1. It cannot be negative value, it cannot exceed 1, right? This is the rule of probability, right? Now let's look at this one. You can read by yourself. Let's look at this one. Let's look at this. Okay, let's look at Z score ni lah. This statement, right? If a student got 70 marks on the test with mean equal to 50 and standard deviation equal to 10, they score 2 standard deviation above the mean, right? So by converting the test to Z score, the and X of 70 will be 70 minus 50 divided by 10, which is divided by standard deviation lah, which is equal to 2. So this is 2 standard deviation, right? So dalam standard normal distribution, right? I forgot to explain about the deviation, right? So we have 3 standard deviation, right? So let's see, make it distill. So remember, another characteristic of a normal distribution, the tail on the right hand side and left hand side will never touch the axis. So it is called as asymptotic distribution lah. So means that the tail will never touch the axis. There will be no probability equal to 0, because the probability of an event is always not equal to 0, right? So this is mu, right? And this is a 1 standard deviation, right? 1 standard deviation, and this is 2 standard deviation, and the last one will be 3 standard deviation. 1 standard deviation will consist of 66%, and this is going to be consist of 95%, and the last one will consist of this one 99.9%, right? So this is the concept of standard deviation in normal distribution. Now let's look at example number 1. So let's notice that the probability value, the probability assignation in this probability example. Let's say I tak my screen hang sekejap Boleh nampak? Alright. So notice that dekat sini, example number 1, we have the probability value. We want to find probability of Z is more than 1.35. So notice the symbol that we use in this probability assignation, right? We are using Z symbol. Z symbol, as we already mentioned to you, Z is a standard normal distribution. So let's say Z is more than 1.35. So from a table, let's say before we go to the table, let's say we need to draw a standard normal distribution. Standard normal distribution is having mean is equal to 0 from negative infinity to infinity. So this is Z, right? So 1.35 would lies on the right hand side lah. So this is 1.35 somewhere here lah. So we want to find this area. This is what we call more than 1.35, right? So we want to know the probability of having Z is more than 1.35. As I mentioned before, if you notice here, dekat atas ni, ada tunjuk kat sini, the total of all probability value is equal to 1. Means that the total area under the curve is always equal to 1. Each side consists of 0.5 area under the curve, right? So kalau kita tengok dekat sini, table ni, probability value ni, listen carefully, this is very important, right? So we want to find to the right area to the right, which is more than 1.35. So 1.35 kita tengok dekat statistical table, cari muka surat. Kalau boleh nampak dekat sini dia punya table of content. You tengok dekat sini basic distribution and significant table. So kita tengok area in upper tail of normal distribution, page number 13. So we will look into table number 3, right? So look at table number 3. This is table number 1, table number 2, table number, yes, this is table number 3. So before we read the table, right, kita tengok dekat atas ni, the instruction dia bagi kat sini. Table number 3, tail of normal distribution. Kita tengok, first kita tengok this one dulu. The area and the shade dekat sini. This is the value of Z, right? 1 minus mu, theta mu is Z lah, Z distribution. Is a cumulative distribution function of a standardized normal variable mu, right? So this is the PDF or probability density function, right? For the probabilities of a standard normal distribution. And kita tengok dekat sini dia kata standard normal variable selected at random will be greater than value of mu. View kat sini adalah this is Z lah. U ni kita panggil Z. So kita tengok formula U, X minus mu divided by sigma. This is the value, the formula. Z is equal to X minus mu divided by sigma. This is a formula that we already look into this table. This notes kan? Nampak tak? X minus mu divided by sigma is same as stated in the table 3. So now we look at the diagram, the standard normal distribution diagram. It select greater than Z, means that they select on the right hand side. So remember the characteristic of normal distribution. So area, total area is equal to 1. So they only consider 0.5 to the right. So 0.5 to the left, dia tak consider. Sebab apa? Kita tahu dari tadi, we know that from the beginning, the area on the right hand side is equal to area on the left hand side. Let's say we want to find this area. Let's say 1.35 is also equal to negative 1.35 to the left. So this area and this area are the same, have a same uh, total area under the curve. So kita tengok sini, dia measure on the right hand side. Boleh faham setakat ni? This is very important. So now, we are looking into Z more than 1.35. Z more than 1.35. So this is going to be 1.35. We want to find this area, right? Let's see. I highlight this one bagi nampak, right? So this area we want to find. So this area same as illustrate as in this table. This table give the value on to the right hand side. Right, boleh faham This table given us the value to the right hand side. So this is, we have column and rows. So this is each column and this is each row lah. So each column and row would represent x minus mu divided by sigma, which is z value, right? This is z value. So they are not giving us the x value, but they give us the z value, which is a standard normal distribution. So if you want to find value of 1.35 to the right, right? So we look into 1.3 dekat sini, 1.3, and we need to find decimal 0.05. So this value, right? 1.35. Nampak tak? Sini, sini. Right? So the probability value will be 0.0885, right? So the probability here is 0.0885, 0.0885. So the area here is equal to 0.0885. And you need to make sure that the value of probability should lies between 0 and 1. It cannot less than 0, it cannot exceed 1. So since the value of 0.885 is lies between 0 and 1, so this is the correct value, right? So if you want to find the value of probability z less than negative 1.35, so negative 1.35. So it's the same method, right? So we want to find the area to the left, negative 1.35. This is the z value kan, negative infinity to infinity. This is z. So we know from the prior information, prior knowledge, the area on the right hand side is equal to the area on the left hand side. If you want to find the area on the left hand side, so it's also equal to the area to the right hand side dekat sini, as long as the number are equal, right? So we can look into the table 1.35, even though they give us the area to the right hand side, so we can mirror it to the right hand side. 1.35 is 0.085. This is 0.0885. Boleh faham the concept? Can you understand the concept? Before we go further, I just want you to know how to calculate the probability for the normal distribution first. Can you make sound? Boleh faham tak?
Yes, sir.
Yes, sir.
Faham, sir.
Mana yang lain tak nampak
Yes, sir.
webcam you? Switch on your webcam. So now, let's look into C dekat sini. So we want to find the value to the left, right? So to the left macam mana itu? Is less than. So kita draw dulu. normal distribution table. This is a Z distribution, Z, right? So with mean equal to 0. Macam mana kita tahu this is a Z distribution? Because the probability is asking, the symbol of probability is Z. So this is a standard normal distribution. So 2.47 is lies on the right hand side, somewhere here. This is 2.47. And this is the area that we want to find. Area that color in blue. So this is the area that we want to find. Now, by looking into the statistical table, mana tadi I nak cancel tak boleh. Right? Statistical table, dia kata kat sini, they only give us the value to the right hand side. To the right hand side. Right? So it will not provide the value to the left hand side. So how to solve this problem? From the prior knowledge, we know that the total area under the curve, the total probability value is equal to 1. So if you want to find this area by looking at this table, we need to do some manipulation. We need to 1 minus probability of Z more than 2.47. It will equal to probability of Z less than 2.47. So kalau kita ambil the whole area under the curve, which is 1, satu tolak dengan area dekat sini, so kita akan dapat this area lah. Boleh faham? So 2.47 should be somewhere here. 2.47 somewhere here. Dekat sini. Right, which is 0.0676. 1 minus 0.00676. Is it? Okay. So we take out our calculator. 1 minus 0.00676. So this area will be 0.99324. So now, to check whether our answer is correct or not correct, right? So first check is the probability value should lies between 0 and 1. So 0.99 is lies between 0 and 1. And this total area on the right hand side is consists of 0.5, and this area consists of 0.5. So this total area should more than 0.5. So we got 0.99. So this is the correct value. Boleh?
Boleh, sir.
Boleh, sir.
Boleh, sir.
Alright. So I just showing you the hard way. So you tengok dulu the hard way. Kalau you tak faham, then you tanya dulu lah. Okay, now let's look at probability of Z more than negative 1.85. So this is a standard normal distribution. Negative 1.85 is somewhere here, right? We want to find the area to the right, right? So because it larger than negative 1.85, so it should be to the right. So how to solve this one? By looking at the third example dekat sini. This is the third example, right? So third example, kalau kita nak cari area to the right, kalau kita tengok dalam table, dia give us the area to the right, but it only provide us the area starting from 0 to infinity. It's not providing us the area from negative infinity to 0, right? So dia start from 0 to infinity. So dia punya stop point is until 0.5 saja, right? So now, let's modify this one. Modify this one. So kita tahu tadi, from the prior knowledge, the area on the right hand side is equal to area on the left hand side. So this is 0, 1.85, right? It's also same to the area to the right hand side, macam ni, sama je. Maksudnya kita akan buang negative 1.785. So sama je macam ni konsep dia. So we will do the same process, 1 minus probability of Z more than 1.85. So we look into the statistical table. 1.85 is somewhere here. This is 0, 1, 2, 3, 4, 5. 0.0322. 0.0322. Is it correct? Yes. So this one should be 1 minus 0.0322. So this one should be 0.9678. 0.9678. Right. Can you get the idea? Do you get the idea?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
Right. Sama je. Alright. So now, I'm going to show you how to use calculator instead of statistical table. If you feel that by looking at statistical table, you will make a mistake, right? There is another way by using calculator, right? So let's say kita tengok dekat sini. Dalam calculator, right? Dalam calculator, the distribution is divided into 3 parts, right? So this is using calculator, right? The distribution is divided into 3 parts. So the first part, the second part, and third part. So this is P, Q, R. The area to the left hand side we call as P area. The area to the right hand side we call as R area. And the area on the middle we call as Q area. Right? Boleh faham ah? This is by using calculator kan? So let's say kita tengok the first one, which is probability of Z more than 1.35, right? So Z more than 1.35 somewhere in the right hand side kan? So now to use calculator, first you need to click on mode and find stat number 3 and dia akan keluar macam ni. Kita dah biasa kan, kita tengok last chapter macam ni kan. But in this stage we don't want to click any of this value. We just click on AC and we need to make sure upper top ni, dekat atas ni, dia tulis stat, S-T-A-T, stat. Now we click on shift 1 and click on 5, which is distribution. So dia akan keluar P, Q and R. So to find this area, which is equal to R 1.35. So klik number 3, 1.35. Tutup kurungan. So you will get 0.088508. So this is the exact value compared to statistical table lah. So benda yang sama kan. So this is by using calculator. So probability of Z less than negative 1.35, we know that from the characteristic of this standard normal distribution is the same as probability of Z more than 1.35. So this one should be 0.088508, same as previous. So now let's look at this one. Probability of Z more than probability of Z less than 2.47. 2.47, we know that we need to subtract by 1 kan. So is less on the right hand side. So kita tekan benda yang sama, 2.47, and then kita jangan lupa 1 minus. So we will get 0.9932443 from the calculator. So this is how we use calculator lah. So now let's look at the this one. So this one, instead of having a single sided, right? So we want to find the area in between. So this is 0. Let's say I tulis kat tempat lain lah. Tulis kat sini, okay. Probability negative 1.56 Z 2.34, right? So let's draw the area first. So never skip drawing the area. So this is the area that we want to find. Negative 1.56. This is 2.34. 2.34. Right. So this is the area that we want to find. The area on the between. Right. Okay. To find this area, we need to do some manipulation. Right. So let's say we take the area to the right. Right. The area to the right. So this is 0, negative 1.56. So let's say to ubah color lain. So this total area to the right, the whole area, minus this area. (2.34). So if you minus this area and this area, you will get the area on the middle, right? From between negative 1.56 and 2.34. So how to do this? We already learned before, kan? How to do this. So this is going to be 1 minus probability of Z more than 1.56. And then minus probability of Z more than 2.34. So by looking into kalau nak guna calculator pun boleh, right? So this one to the right kan, kalau kita, this is also equal to, kejap right. So kalau kita compare kan, macam mana kita dapat this one? Let's say I draw this another curve kan. This one is also equal to this one. This is 0, 1.56. If you want to find to the right, to the left, benda yang sama. So the area are equal, right? To the right and to the left, right? So this is the concept lah. You need to understand. So now, by using calculator, let's say we want to find the area to the right because we don't have in the statistical table we don't have the area to the left, but we can also use this kind of manipulation, or if you want to stick with this one also can, but later on I will show it to you. So let's say 1 minus distribution to the right, which is 3, 1.56. So this one should be 0.94062 minus, and the area to the right inside, which is, ni lagi senang kita nampak kan, 2.34. So which is 0.00 di 3 kali kan, 96419, right? So lebih kurang sama lah kalau kita tengok calculator table nanti kita tengok jawapan dia. 94062 minus 0.0096419. So it should be 0.93097. So this is by using calculator lah. So okay, I think it's also okay. This is a hard one lah. This is a hard one. If you still, we don't want to remember PQ and PQ, kita boleh guna R saja. Let's say kita tengok guna statistical table, right? 1 minus 1.56. 1.56 should be 0.059. 0.0594, right? Is it? Yes. And then 2.34 should be somewhere here. Oops. 0.0964. 0.00964, right? 0.00964. So if you look at the calculator, 1 minus 0.0594 minus 0.00964. So it should be 0.0939096. So still give us the same answer lah, right? So this is the hard way of using calculator. Which is 1 minus R 1.56 minus R 2.34, right? Now, I'm going to show you another way. This is very simple way to get the answer. So remember tadi, I cakap tadi, this one. If you want to find the area on the middle, we're going to use Q, right? Instead of using R, which is to find the area to the right hand side, we're going to use Q to find the area on the middle. So this one should be probably Q, let's say Q negative 1.56 plus Q 2.34. So this is going to be very easy. Kalau guna calculator lagi senang. So negative 1.56 plus 5Q 2.34. So still give us the same answer, 0.93098. Benda lebih kurang sama lah. Okay. So I think the third method is more convenience compared to the hard way by using calculator and statistical table. We just need to use this one. But in final exam or in your final exam or test, you need to write down the basic concept, which is this one, this formula, 1 minus probability of Z more than 1.56 minus probability of Z more than 2.34. Right? You need to write down the classical concept, right? So the calculator is just to confirm back whether your method is correct or not correct. Boleh faham? Apa yang cakap sekali lagi? Dalam final exam, dalam test, I want you to write down this method. If you don't have this method, this working methodology, so we will not get any marks, right? So you are using calculator to confirm your result. Itu saja. So this is E, right? So let's look at F, which is 1.45 and 2.56. Oops. (1.45, 2.56). Right, let's look at this one. So we want to find probability of negative 1.45 to the right, right? 1.45 Z 2.56. Is it? Yes. So this one is quite different. So we want to find this area. Instead of having on the middle, we want to find the area to the right. So this is 1.45 and this is 2.56, right? So we want to find this area. Okay, so how to find this area? Very simple. Let's narrow down the distribution curve. So let's say we want to find, we have the whole area on 1.45, right? The whole area minus with the area 2.56 to the right. 2.56 to the right. Okay, so then we will get the area between 1.45 and 2.56. So now, by looking at statistical table, probability of Z more than 1.45 minus probability of Z more than 2.56. So 1.45 should be somewhere here, which is 0.735, 0.0735, is it? Yes. So 2.56 is somewhere here, 2.56 here, right? 0.00523 minus 0.00523. So by using calculator, 0.0735 minus 0.00523 should be 0.0682. 0.0827, 0.06827. If you are using calculator, R 1.45 minus R 2.56. This is to confirm back whether your working is correct or not correct. So R is 3, 1.45 minus R 2.56. So 0.0829. Benda yang sama lah. 0.06829. So the calculator is calculate more accurately compared to statistical table. So this working will give you marks. This working will not give you any marks. This working by using calculator ni hanya untuk confirm back whether your working is correct or not correct. Boleh faham? Any questions so far? Do you understand?
Yes, sir.
Yes, sir. No question.
Yes, sir.
Yes, correct. So it's the same concept to the left, right? To the left also same concept, right? So kalau kita tengok dekat sini, this is 0. We want to find negative 1.56 to negative 0.46. So this is the area that we want to find. So better when you have a final exam or a test nanti, you standby your pencil color to shade the area. So this is also equal to this area, right? Remember the characteristic of standard normal distribution. This is from 0.46, 1.56. This is an equal area, right? So the concept are same, right? So you can find probability of, probability of Z more than 0.46 minus probability of Z more than 1.56, right? You can find by using a statistical table. Okay? Ada soalan tak? Sebelum we go to the next example, which is example number 2. Example number 2, we need to think a bit harder. So this example number 1 is a basic concept of finding a probability from a standard normal distribution. Okay? Soalan? No question? Then we move to the example number 2. Now, let's look at example number 2. Before we go to example number 2, we need to understand, really need to understand the characteristic of normal distribution. So again, I just draw again. This is a normal distribution. That's why I already emphasize the characteristic of normal distribution again and again. This is very important. This is Z distribution. So we know that the total area under the curve is equal to 1. The area on the right hand side is 0.5. Area to the left hand side is 0.5. Right? So this is the basic concept. Right? So whatever area, area dekat sini to the right is also equal to the area to the left, provided this is having a same value. Right? So this is the basic concept of standard normal distribution. Right? So now, let's look at this one. Probability of Z more than K equal to 0.1. So we know that the total area dekat sebelah kanan is 0.5. On the right and left hand side is also 0.5. If you want to find probability of Z more than K, right? More than K is 0.1, means that the area is to the right, right? It consists only 0.1% or 10% of the area in the probability distribution. This is the K. So the question here asks us to find the value of K. We want to know what is this value. To find this value, we can refer to statistical table, either table number 3 or table number 4. So table number 4 is given us the different value. So but look at the table number 4, page number 14, right? Table give us 100% alpha percentage point mu alpha. Mu is our Z. Remember, this is a standard normal distribution, right? Of a standard normal distribution. So this is the PDF of alpha. Right? Don't bother about the formula. So look at this one. Look at the diagram. So it only give us the area to the right. Area to the right. So this total area is 0.5. So that's why kalau kita tengok dekat sini, the maximum value of alpha is 0.5. Sebab dia bagi area to the right hand side only cover 0.5% or 50%. 0.5 of probability. So alpha here is the value of the shaded area ni, right? So mu alpha is in our case, in our example is K, which is we want to know what is the value of the probability that we want to find. So now look into this one. We want to find the value of K where alpha is equal to 0.1. So we need to find alpha 0.1. So alpha 0.1 is 1.2816. So K here is 1.2816. Boleh faham? Now, let's look at another example. We want to find the area of K less than K, which cover 95%. 95% or 0.95. So remember the characteristic. The first half is 0.5, another half is 0.5. If you want to find the 0.95 area is 95%, it should be cover at least 95% lah. So this is the area to the right hand side, to the left hand side, because Z is less than K. So we know that this is from negative infinity to infinity. So this is the value of K that we want to find, right? And that's why I told you again and again, you need to remember the characteristic of normal distribution, right? So dekat sini, let's say we want to find this area, right? K dekat sini sama juga, dia boleh cover, let's say K dekat sini, dia boleh jadi, kalau this one, we can find probability of Z more than K. Sama dengan berapa? 0.05. How I is the balance of 95%. Right, so this is 0.05, K more than Z more than K is 0.05. So we look into the statistical table. 0.05 is here. The K value should be 1.6449. So here 1.6449. Boleh faham? Do you understand?
Yes, sir.
Yes, sir.
Right? Okay, now let's look at the next example, which is Z, probability of Z more than K covers 75% of the area. So remember tadi, first half cover only 0.5 or 50%. So if you want to find the cover 75% of the area, this is the value of K, negative infinity to infinity. So this area will cover 75%. So nampak macam sama kat atas lah, sebab the area tu you kena adjust sikit lah. Right. So this covers 0.75 and this area will cover 0.25%, 0.25 or 25%. So this chart, this diagram is also equal to this part. Kalau kita terbalikkan, so this is going to be a negative K, right? But they're on the right hand, on the left hand side. This is going to be a positive K. This is from negative infinity to infinity. Let's say I'm using another color. So this is the area to the left hand side. So this area would cover 0.75. This area would cover 0.25. Right. Since, kenapa kita kena convert kepada sebelah sini? If you are looking into this statistical table. So, different books have a different type of statistical table. Dia akan bagi different value of statistical table. But in our reference now, statistical table number 4 ni, it only give us the value to the right hand side. So that's why by converting it to the right hand side, so kita akan clearly see the value that we want to find, right? So now di sini apa? K more than K, Z more than K, probability of Z more than K is equal to 0.25. Let's say we want to find this area. Kenapa kita ambil yang sikit ni? Because in our statistical table only provide until 0.5. Okay. So now, more than 0.25. So 0.25 is somewhere here. Dekat sini. So 0.25, K should be 0.6745. So K here, for this chart, K is equal to 0.6745. But in our problem here, is Z more than K is 75%. So K value here should be negative 0.67. Boleh eh? Okay. So this example, It's a still same as previous example, sama je. Kalau kita convert dekat sini. So this area K is Z less than K is 0.25. 0.25. So K should be negative 0.6745. Benda yang sama lah. Right. So just do some manipulation bagi you confuse saja. Okay, boleh? Any questions so far?
No, sir.
Alright, good. So next, we try to look into example number 3. I think we don't have enough time lah. So I think we continue on the next lecture lah. Example number 3 and so on. We need to go more faster than this because I hope you already understand the concept of finding the probability value from a statistical table and calculator. This is for standard normal distribution, right? So later on, next class we will look into a standard normal, original normal distribution. Not this is a problem from our original normal distribution, and then we try to convert it to the standard normal distribution, right? So I think that's all. We continue on the next class, right? Ada soalan before we end our session?
So far, no question.
Okay, good. I think that's all. Thank you very much. Assalamualaikum.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you,
Salam.
sir. Salam.